going to get a screen share going over here. Oh, look, I've got some Astro documentation because I was curious.
Yeah.
All
Um,
right.
there we go.
Hey, y'all, it's the 18th of September, 2024. This is Plutus PBL Live Coding. We're working on a couple different things, and that's where I was hoping to start us off today. Can I find Gimbalabs? I have the calendar. Let's go to GitHub, Gimbalabs. So there's a bunch of different repositories at Gimbal Labs GitHub, and all of the ones that start with PPBL 2024 are the ones that are relevant to us for Plutus PBL. So we've got some Plutus examples, transaction examples, Aiken examples, and the front end. Now, different elements from different repos break at different times. So, for example, Aiken just went to version 1 and beyond, and they took the alpha tag off and they published a couple of breaking changes. So, we do have some changes to make here. If I just look at this repo for a second and we go into, let's just look at the faucet as an example. This was using Aiken standard. Where actually, I actually don't know where to find it. Aiken by, I don't know what 1.90, but in any case, the version for this project right here is a little bit behind where Aiken is, and we've got some things to fix. So without going too deep into the details right now, that's one example. And then we've got in the Plutus PBL front end, after the hard fork, we know that a couple things broke, and we were making progress on fixing that last week. So we already have a Notion board where we're keeping track of big picture ongoing work at Gimbal Labs. And a lot of that work is non-technical, so tracking it in Notion makes a lot of sense. But sometimes when you're working on software projects, it's really helpful to have things in your Git repositories. And that's why we have things like issues. So in the Aiken repo, for example, we have an issue update with new version of Aiken. I just made this 30 minutes ago as an example. And we can add as many issues as we want to keep track of work. And this is how teams get together and plan and set priorities. So that's all well and good, but we've got several different repos that we have to pay attention to. And maybe there's issues in some of these other ones as well. So when that's the case, what we can also do is we can look at a project in GitHub. Now, this is not a Git native function. This is a GitHub feature. Okay. So we don't really have, you can't like go to the command line and manage this with just Git itself. You could use like the GitHub command line tools. But for now, this is a fine interface. We've got a little, board right here where we can move cards across. And here's what's really cool. You see how this card right here is the issue we just looked at. This is in the Aiken examples repo. But over here, we have a different issue. This one is from the front end repo. And this is where we left off last week, fixing the PPBL faucet transaction. That's why we can say this is in progress. And it comes from a different code base right here. So this is a really nice way that we can start collecting tasks and pulling them together from the different code bases that we rely on. All of this integrates with Notion. We're experimenting with that on the Andamio team right now, and I'd like to do the same, but that can be more of an open spaces or just informal kind of governance conversation that we have. I think this is enough to allow us to, in an emergent way, kind of track what we want to do and set priorities during these sessions. Any questions about that so far? Hey,
Nope.
Sarah, Mix, Adrian. Hey, guys.
I am kind of curious. I've randomly also looked at the projects in GitHub. this week. And it matches that exact same thing. When you've got multiple repos, you can manage them all in one spot. I didn't quite think about that it's not Git native, it's a GitHub thing. I'm curious if other Git places have it, but it is powerful. There's a lot of like automation things you can do. You can do like meeting, like sign off. There's tons of incredible deep stuff that goes in there. Yeah. So I'm tracking. I'm curious if Mix, Adrian, the other developers here use this, and is it like, oh, that's great, or is it like, I don't know. And we can also, naturally, this would be something to bring up in the open spaces. It does fall into like, okay, we're changing something, and it would be like a governance issue. Yeah, or design. This is the design of Gimbalabs, and like, oh, it could be a
Playing with
proposal. Yeah.
Well, and playing with those integrations is really cool for people who are technical, but maybe not full on developing every day, right? Like all of us are hackers. Not everybody's writing code every day, but all of us like to hack tools together. So playing with the integrations between GitHub and Notion, for example, and eventually extending those integrations into the way we're handling contributions in Andamio, all of that's really interesting. We get to work with existing tools, we get to work with new tools, play around with the Web3 part, see what we find out.
I love it. Yep. The
So yeah, all that's
integrations. Yep.
yep. So I was thinking we would focus on this one first today, and then if there's extra time, look at Aiken. But is there anything else to add to this board? Chris, did you want to ask any questions about your current work, or are there any other priorities that we should set? Cool. So we'll spend some time on this one today. Before we do, I just wanted to share one fun update. We are going on hiatus from Cardano Go live coding, which has been meeting most Mondays for the last few months. We're wrapping up the scope of the Fund 11 proposal we worked on, and now moving into thinking about where that goes next. So I've actually been working today on closing that out, but just wanted to share one fun thing that's going to drive future course content, whether all of it fits in the Cardano Go course that's also being built. You can see that right here, right? Looks similar to PPBL, and it covers if you really want to go the Go route. This is something we can cover during these sessions if it's ever useful. But this course is going to continue to be developed. And one of the outputs of this work was Andamio CLI. So this, as of a few hours ago, it has its initial public release, version 0.1. And it can be downloaded on any platform, and it's a command line tool like Cardano CLI that feels a little bit familiar if you've been playing around with Cardano CLI, that allows for access to Andamio functionality. And this is a fun project because it, just like looking at a front-end web framework in TypeScript, right? Whether it's React or Astro, right?
Hmm.
Go gives us the ability to, in a similar way, build command line tools, little utilities that just come in handy all the time. And so just to give you a little peek at what this does, it won't look very surprising. We can say Andamio CLI, and we can see what kind of commands are available. We can say query, and we can see what we can query, whether it's the course or instance validators, that kind of thing. And we can eventually get down to the point where we are looking at useful data, well, modules. And let's list the modules for a given course that's identified by a policy ID. I have one of those off screen, just gonna grab it real quick. This one. Nope, not that one. How about this one for now? Oh yeah, no, there should be one there. Yeah. All right, so just for example, if I specify a policy ID, I can see a list of modules and student learning targets for which credentials can be issued. And so this is all being drawn from on-chain data. It's all represented in the front end, but now we have this nice developer-focused tool because the point of Andamio isn't just to deliver the front end that's currently at andamio.io, but to build out a network that other folks can build applications on top of, right? So just like working with Cardano CLI gives you exposure to the underlying form of UTXOs and transaction building, this tool is going to come in handy. What's different from Cardano CLI is we have all of the source code right in front. Well, I guess we have the Cardano CLI source code in front of us too. But this was made, right here with work we've been doing, and we can all continue to learn from it if it's helpful. So just wanted to celebrate that and let everybody know that's there, that this is a direction we can go anytime. Any questions about that one? All right. So we'll come full circle to that. We'll keep adding to our backlog, but for now, let's take a look. I'm just looking at the chat. I know it's really fun to share that like these outcomes, Newman. Thanks. All right, let's take a look at the code base for the front end. And my screen's doing that weird thing that it does with Zoom sometimes. Gotta stop sharing for just a moment. That's where we want to be. All right. Try again. Okay, so this is nearby where we left off last week with the PBL faucet withdrawal transaction. And so there's just a little bit of cleanup to do. I just pasted some code in here on the wrong line. So the first thing we've got to do is just move that around, resolve a couple errors, and look for this getEnv function. Where was that? That's built in, isn't it? Oh no, it was defined here. Okay. We do a lot of inefficient things in the PBL code. And we were actually talking about this in Go Live Coding as well. In some of the initial components we want people to get their hands on, we want the component itself to be comprehensive, right? So best practice is to never repeat yourself. And anytime you have repeated code, to extract it to some file where it can be imported somewhere else and reused. In like tutorials, that's not always the best approach, because if you make a tutorial that has all of these abstractions and imports to other places, that can overwhelm people and distract them from the real focus. So you see this function right here, this little getEnv function that's used down here. This is just a helper function that takes some key, right? Some environment variable we're looking for, and returns it if it exists. And instead of importing this over here, I'm just going to copy this function, okay? And paste a copy of it over here, breaking that fundamental rule, but making sure that this file is complete. Then look at how that's used. This get env is used when we get our Maestro API key. We actually don't need the signing key because we're not minting right now, but the Maestro API key. And that's going to be outside of the function we're actually writing. Here's our PPBL token minter, right? This is its own function. Above that function, we have some helper stuff. So right here, I shouldn't have dropped all of this stuff in here. Let's grab this and move it up here. Okay. And then we've got another select UTXO with most project tokens. That's fine. We'll talk about that one if we need to. And then we don't need this minting script. And Maestro provider, we want to import that from Mesh. And now we should be getting closer. There we go. Okay. And this is calling a Maestro, which is actually this Maestro provider right here. So I'm just going to change the name of this. And good. Okay, so now at least this stuff up here at the top of the file looks a little better than it did before, but we still haven't rewritten the transaction itself. And so this is where we have to pause and talk a little bit about the progress of the Mesh SDK. All right. So a few different updates to Mesh have been pushed over the last few months. Some of those changes were planned internally by the Mesh team. They've learned a lot about how they want to structure the Mesh libraries to make them as useful as possible to people. And so an example of that, and this is what we started to look at last week, we will look at more today, is just in the way transactions are built. There used to be different methods that you could call when building a transaction that didn't really match, for example, the inputs you would have on Cardano CLI, right? So a lot of us are familiar with Cardano CLI, transaction build, how to get inputs, create outputs. Those outputs can have receiving addresses and Lovelace and other tokens, Datum, for example. But that send assets doesn't map directly to that. So one of the design decisions the Mesh team made is that they wanted building transactions with Mesh to optionally be more like building transactions with Cardano CLI. So that's the main thing we're going to update today, right? Is this transaction building to use those new methods. But at the same time, there have been other updates to Mesh related to the Chang hard fork. Okay. So examples of those would be updating cost parameters, making sure that any transaction with validation in it evaluates correctly, so it can be validly submitted on chain, right? So all those changes have rolled out kind of in parallel. Mesh team has released some other really cool stuff too. They created a front end portal for creating multi-sig wallets. The reason they decided to do that now is they want to have multi-sig DREPs accessible to anybody. So there's been lots of additional cool work happening over there. But at the end of the day, we can split it into these two parts, right? What's new based on the new Conway era, and what's new based on just the ongoing work of the Mesh team. Any questions about that synopsis or the first thing we need to do right here?
So it's basically Mesh is trying to make it more like Cardano CLI. so that there's maybe some, similarities between, so we're not using kind of a different, language altogether, or different, way of doing it altogether. And then there's also some stuff that happened with the Conway Cheng hard fork stuff,
Mhm.
basically,
Yeah.
or not. Yeah.
No, that's exactly it. Does anybody else have any thoughts? Questions, insights? Did I miss anything? All right. So there's documentation, and actually the docs are still in development for some of this stuff. So what I'd like to do actually is go back and forth between a transaction that's already built. One of the first things I built with the new mesh libraries is the contributor prototype that we've been using at Gimbalabs, right, to handle that treasury. You've seen that front end. There's a lot of changes to come with that. And rather than going too deeply into that, we can use this just to look a little bit at the syntax of these transactions. Okay, so what we're going to do is go back and forth between this old version of this withdrawal transaction and the new syntax that's available to us. And if we do that, hopefully piece by piece, we can clean up the code that until a moment ago was just on my screen. Let's go over here. Okay, so here is an example of this is the contributor commitment transaction. So anybody who holds that contrib token, when they commit to a task in the prototype, this is the transaction that's being used there. It's substantially more complicated than the faucet one, but the patterns we can see here are helpful, right? So what do we have? We have TX in collateral, right? That maps to Cardano CLI transaction build. And then there's the dash dash TX dash in dash collateral, which you would define in a CLI transaction. So first thing to notice is that in many of these cases, TXN being another one, where on Cardano CLI, you might have dash dash TX dash lowercase I N. In Mesh, it's the same words, just dot because we're combining methods on this mesh object. Don't worry about the dot too much, but we're just taking TX in and turning it into camel case with no dash, okay? This is really nice because now I can start to use my Cardano CLI transactions that I've already built and tested and convert them pretty directly to this format. In some ways, we're losing. Let's look back over here at this old example. Previously in Mesh, we didn't have to define collateral explicitly. And that was actually a really nice feature of Mesh, right? We could just say, hey, I want to send some assets. And that we already started making some changes here. So this actually isn't a perfect example of an old transaction, but just look at this bit right here, send assets, right? If I wanted to send some tokens from a connected wallet to some other wallet, in the old version of Mesh, all I had to do was define these send assets methods, give them addresses, which, because this is called, they were calling this a recipient type, it was actually with the address that you could optionally include some datum and some assets, right? Now, that whole piece about datum being coupled with the receiver address, you can see the inconvenience of that. It's not really intuitive based on how datum works, but what this approach allowed for was that when you were building an application, you didn't have to explicitly define what the inputs and outputs to the transaction would be. You could just say, hey, use the connected wallet, build a transaction that sends these assets to somebody else, select whatever UTXOs are necessary from the wallet, select a sufficient collateral UTXO from the wallet if needed. And by the way, handle sending change under the hood as well. We lose all of that by moving to this approach, but we gain a little bit more hands-on control over precisely how we're going to build transactions. So I hope you can see that trade-off, and I hope you can see why Mesh was initially built this way for convenience, but maybe you can imagine how along the journey of building that, trying to build for convenience actually made it harder, right? Because there was this different set of abstractions that didn't really map to what people understood. How much sense is all that making?
I got it. I mean, that makes sense in this idea that there's a Cardano CLI and that this mesh is another abstraction. Yeah, I get it that there's two different types of transactions and it kind of clanged and now they're making it sort of harmonize or rhyme with the with this other one. You know, they're like, oh, okay. Because otherwise you're like, why can't I? And I think it's a good analogy. It's like under the hood, it's a little helper that doesn't matter like where the collateral comes from. It doesn't matter where the inputs, outputs. So just say send this asset. And yeah, so that makes sense to me. You know, uh I still I don't have the low level of it, but I that makes sense. And then it also makes sense why they would want to change it, you know?
So on that low level point, let's go back over to, oh, I used a different page. So let's do this. Let's go back for just a second to our project board. Oh, thought I was closer to it.
You
That,
could
let's do this
go,
instead.
yeah.
Here we go. I need to jump into Gimbalabs. I want to see this project because this, I think this idea of thinking about the low level is actually really interesting because now that we have this, you could call it, right, a lower level version of mesh where we have more hands-on control. One thing that immediately follows is that, well, shoot, now I have to select collateral on my own. But
Mhm.
actually, that's a helper function. And there's actually a few different places you can get that helper function. But as an exercise, writing a
Right.
get collateral helper function, I think is a really, really cool thing for students to do.
Yeah.
And this can bridge the gap between kind of that lower level understanding. Yeah, what are the nuts and bolts of this? And ultimately the fact that, yeah, I don't want to rewrite like how to get collateral every time I build a transaction. So I'm going to add a task here I'm just going to make it a think about task for now. No action necessary, just something to think about. Let's think about um, helper functions that PPBL students can write as exercises that provide utility with new mesh TX building, right? And an example of that would be um, the get collateral UTXO function, right? So I can go in
And you
here and add some details on the, here's my card is the title. But I can say, for example, how about building a get collateral UTXO function, a reusable get collateral UTXO function. So there we go. There's a note. It's just a draft. It's in the to-do column, and maybe we tackle that at some point. All right. So we've got this transaction. We are going to have to do that exercise right now. That'll be fun. We can use txin, which just like Cardano CLI requires the hash and the index of the UTXO. Instead of writing it as a string with this string and then the hashtag and then the integer, these are just two comma separated inputs to the txin method, right? But the idea is exactly the same. Sometimes UTXO inputs are, oh, that's not the example. This is contributor fees. Let's highlight this part right here. Okay. So sometimes UTXO inputs like this one come from a treasury address. And here's how you would define them. You specify first, oh, we're about to use a Plutus V2 spending script. Then you say which UTXO you're going to unlock with that spending script. And then you identify the datum, whether it's inline datum present or whether you're providing the datum in some other way. You'll always have to provide a redeemer to spend value from a validator input. And then right here, because we specified, oh no, we didn't already. Okay. And right here, we use spending txin reference. And this is the reference script for this transaction. Now, just for fun, let's actually open up Cardano CLI transaction build. Okay, and here's the long documentation. Obviously, there's a lot more than we really need right here, but I'm curious about some of the txin stuff. txin. So here's our regular txin. That's fine. But we are using a spending Plutus script v2, for example. This is how we would specify it. Dash dash spending dash Plutus dash script v2. And you can see this doesn't take any additional arguments like txin does, right? But right over here, here's the perfectly corresponding method for that. And it's got open and closed brackets because there are no additional parameters on this, like there would be with txin. So hopefully you can see how this maps directly to this right here. We also have in the mesh code txin inline datum present. That's always been a mouthful. But where is it? txin inline datum present. There it is right there. Same exact words, same story. We're moving from dashes over to camel case, but there they are. Open and close brackets, right? No additional parameters, which is exactly what we see right here. If I was supplying datum by some other way, whether as a JSON file, right, datum file, I would supply that file, or as a value, I would supply the value. But if there's already inline datum, I just say, well, there's datum in that UTXO, use it. And then we've got redeemer value, right? So we're using this in the transaction over here. And you know the idea by now, right? The names match. This one does have two parameters. It has the name of this variable, treasury action commit token, and then it has the type of this redeemer. So first, let's look at Cardano CLI. Redeemer value, there it is, takes a JSON value, but that's only one argument. This one over here, we're passing two properties. okay? But you can see a little bit how this works. We're saying this second one is just to say what kind of data this right here is. And if you look in the documentation for Mesh, you'll see there's a few other options. So you can supply the redeemer as CBOR, for example, instead of JSON if you wanted to. This redeemer, let's try to find it, is defined up above on line 105 like this. And you can see this looks pretty similar to what a redeemer looks like in a JSON file when we build a transaction with Cardano CLI. Constructor, fields, there's our type right there. Okay, so we're going to have to define something like this, but this is the format we're asking for when we give that JSON tag down here. Okay. And then finally, spending TX in reference. Can we find something like that? Let's see. Spending TX in reference. There it is. Right? And this is the TX in the ID and the index of the transaction, which is exactly what we see right here, the hash and the index of a transaction. So it all maps one-to-one. This is a big part of what we need to implement right now for the faucet. As you can see, a transaction can unlock from multiple validators in the same transaction, but we're not going to need to do that in the example we're working on right here. Any questions at this moment? Just for fun, yeah.
Oh yeah.
All right. All right, so now this thing is a mess. We left a little partially complete situation over here. So let's figure out what we really need here. The faucet transaction. I'd like to actually go to the lesson about this one for just a minute. This is a good chance to find out if the original description was good enough. No, we really didn't go too deep into it, right? So this is being introduced at the very beginning of the course. People have just minted an access token, and now they're finding out that they can connect their wallet. Oh, you see, look, this is what we're fixing right now. Yes, we do need to fix that. Yep. So we see the example in the live examples page, but we don't really talk much here about how it works. Later on, however, we say, okay, we show you how to compile it. Where do we look at the code itself? Maybe in the transaction? Yeah, okay, here's our faucet transaction. Good. Robbing the bank. Yeah, we can reframe that. I love that. Bond's a genius. Right. So rather than calling it a faucet, let's call it a bank. And instead of saying we're unlocking, that word just doesn't have enough emotion in it. We're going to rob the bank instead. But the idea is the same. And here's the transaction we really need to implement. What's going on? We're unlocking from a single validator. Here it is, right? We say, okay, unlock this UTXO with this spending TX in reference. It is a spending Plutus script version 2. It has inline datum and will supply some redeemer. Excellent. We need inputs from a connected wallet, one for fees and one that includes the PBL token that was just minted. No, don't change it. And then we need collateral. Okay, so we're gonna have to get these three. The reason we ask for two separate UTXOs right here is that we can't guarantee how much Lovelace there will be in the UTXO that has the PPBL token. It's possible that this UTXO right here has enough Lovelace to cover this transaction. But since we don't know, there's no harm in grabbing another UTXO that has just a bunch of Lovelace in it. Okay, so we're going to grab both of those. But what's nice is that once we identify this UTXO, we also can use it as collateral. So that's really nice. This is, once again, that's the validator stuff. So we're going to use that. And then we're going to have a couple of different outputs. The connected wallet, the owner of this PPBL token, is going to get their PPBL token back. We're just going to hard code, yeah, give them 2 ADA in the UTXO with that. And then they're going to get 100,000 faucet tokens to the same address. We're also going to lock 2 ADA with that. And then we're going to send the rest of the remaining faucet tokens back to the validator address. And when we do, we want to include the datum once again. And this just shouldn't change from whatever it was in the old inline datum, right? That's what the validator says. Just make sure the datum is still the same. Any questions about this transaction? Now, this, of course, has to be updated because we are moving into using Conway era, right? So it used to be that we said Cardano CLI transaction build, and then we could specify an era here. But if you've already been playing around with this, you know that now it's Cardano CLI Conway transaction build, and we omit this line. Nice. So that sounds like another thing we got to work on. So I'm going to add that to the to-do list. I'm going to add another item, right? Update module, what was that? 202, 102. Update module 102 with Conway era transactions. Cool.
And is that the only, is it just, adding Conway to the command line parameter and then removing it from the I guess those are all flags.
Right. In this case, yes, that's sufficient. But looking ahead, soon we're going to want to play around with some Plutus v3 scripts. And that opens up a whole other realm of examples we might want to add. So, for example, where in Plutus PBL should people build their first governance transaction? Should we show people how to register as a DREP on pre-prod early in the course? Is that interesting? Right. So there's a lot of questions that we can follow up with. Chris, what do you think?
Yes, I want to ask you something about the transaction build. You say that in the TXIN, you include the TXIN fees and also the UTXO where we have the PPBL 2024 token, right?
Yeah.
So I want to ask you, so if we don't have enough UTXOs in the PPBL token, we use the UTXOs from the TXIN fees, right?
Correct.
And also
Lovelace from the fees UTXO. Yeah.
yes, and that's gonna cover the collateral, right?
Right.
But
Well, if it's big enough, right? So this is where if we want to use this TXN fees as collateral, we probably want to guarantee that this UTXO has at least 5 ADA in it.
okay. But if I have enough UTXOs in the PPBL 2024, sure. I mean, can I build a transaction without the first one, the TX in fees? Let's say I have enough UTXOs. It
You have,
works.
well, and let me just correct the language a tiny bit right there. This is one UTXO. So we're talking about a single UTXO. You're asking, does this UTXO cover the fees?
Yeah.
Does that make sense?
I'm sorry, I don't have a good signal. I didn't hear what you say.
That's all right. Where your question is about finding out if we can spend just one UTXO, right? And the question is, does this UTXO have enough Lovelace to cover the fees?
Yes.
If it does, then yeah, we can ignore this line right here, but we would still have to find a collateral UTXO.
All right. Yeah, I got it. Okay, thank you.
Mhm.
Hey,
All right,
Gene,
I'm going
guys?
to,
Oh,
go ahead.
yeah. Hey, sorry, I came in a little bit late, so
Hey,
I
Caesar.
already answered
Yeah.
this question. Hey, what's up? Just adding with the collateral and transaction fees, the one that's highlighted right now. What's the collateral for? I don't really remember what this lesson was about. So what we were talking about before was that transaction in PBL 2024. That's assuming that has some ADA attached to it, right? Some Lovelace attached to it. So if it does cover the transaction fees, we could ignore the previous one, TX in fees. What I'm wondering is what's the collateral for?
Excellent. So anytime you build a transaction that validates according to validator rules, right? So, and when I say that, I mean any transaction where you're using a smart contract, you must provide collateral. You don't have to do this when there's none of this bit right here. Okay, so this is the section that makes collateral a necessity. If I deleted these lines and my only goal was to send some tokens to somebody, I could ignore collateral as well. But what's the purpose of this collateral? There are edge cases where it's possible to build a transaction that validates according to your smart contract logic, but is invalid on chain. And transactions that fit into that small subset can be used to spam the blockchain. Okay, that you could, there's attack vectors that could be exploited here. And so the solution to this is to say, anytime you build a transaction where you're going to be having some kind of smart contract interaction, you supply a collateral that if you build one of these edge case transactions can be consumed. All right. And actually, where is it sent? Adrian, do you know this, or Mix? What if a collateral UTXO is consumed, where does that Lovelace go?
It should be the same place as the transaction fee.
Okay. So
Because
it's treated as a fee.
because the collateral is you can think of it as reward for the stake pool operators, because they had to do some calculation to calculate that your script is not valid.
Very nice. Okay. So this is the collateral is here, Caesar, just to answer your question briefly, as a protection mechanism against this edge case. Yeah, and as it'd be a fun exercise. I've actually never built a transaction on pre-prod where the collateral gets consumed. Have you guys done that?
I think it's not really possible as long as you are having a the normal node. You can modify your node, and also I think there's a tag for it. There's some
possible.
script invalid tag.
Can you hear me, guys? Want to
Yeah,
talk?
got you.
It is possible. There is a guide actually. If I find the link to that, there is a guide for how to do it, how you can make a transaction that fails. So I don't know if it is possible still in this era, but it is possible to do it. But I will find that document. I think it would be in Plutus repository, something example of that. But there is a guide how you can do that. Yeah, look this
That's a
up if
fun
you-
challenge exercise. But Caesar, how do you feel about that?
Yeah, that makes sense. I'm assuming this is what prevented that attack that happened a few months ago, where the guy tried to attack, or the person tried to, you know, to try to attack the blockchain. And I'm assuming this is what made it expensive, or what makes
Yeah,
it expensive to do so.
I was about to ask this about this. I heard about it, and I think they stopped the attack because of this.
Yeah, I'm trying to remember the exact details of that. What did he use a zero withdrawal
Yeah,
transaction?
he used
That's with
zero
staking.
withdrawal, and in the old version or before the hard fork, you could just append as much reference scripts as you want without paying anything. And so he just wrote a big script, and that was costly to deserialize for the stake pool operators, and also the blocks were filled fast. But since the hard fork, you have to pay a little bit for deserializing a reference script, and now it's more expensive to do that attack.
Seems like a successful story then. All right, let's take this transaction and I'll drop this in the chat, by the way, just in case anybody wants to keep following along with this. But now I'm going to move back here and go line by line through there to make sure I'm representing this whole transaction here in Mesh. I'm just going to give myself a little bit of space here and then go back and delete some of the things. So I don't need to specify the era or testnet magic anymore, but I do have two TXNs from the connected wallet, the TXN collateral, and then the one that I'm unlocking. Now here's the unlocking section. This part actually looks good. We'll check on this in just a second, but that's pretty much what I want there. But before I get to that part, I just want to have a TX in, and this one's going to be for fees. I'm going to have another one for my PPBL 2024 token. And then I'm going to have a collateral, TX in collateral. Obviously. Okay. And I'm putting placeholders here, right? So there's going to be errors all over the place because each of these requires some properties. But in terms of my outline, when I'm looking at this on both screens, it looks great. Okay, I'm going to follow this then with this right here. There's my input from the faucet. That's nice. And then I'm going to keep these for reference for just a minute because there might be some things we can reuse, but I'm going to want a couple of TX outs. TX out for the faucet token to wallet. Another one for PPBL 2024 token back to sender. And And I should, yeah, let's back to wallet, to connected wallet, and this will be the same right here. Okay. And then we have one more TX out. This one is going to faucet validator. And because it's going to a validator, it needs datum. Shoot, I don't remember the name of TX out inline datum file, right? And that's frustrating for a second. But then I remember that it's exactly the same as Cardano CLI. TX out inline datum value. Perfect. There it is. And that's going to take the datum. Now, this datum, I've actually already built it down here, outgoing datum. Let's just use that outgoing datum in JSON format. And that should work for the datum value. Now, TX outs, it says expected 2 arguments, but got 0. What are those arguments? We need an address and a list of assets, right? Well, I've already started collecting addresses here. Address in these send assets is just from the use address hook up here. And that's the connected address. So that's actually where we can send our value here. Connected wallet, that's address. And that's going to be address. That's very nice. This right here is the faucet address. It's not stored as a variable for now. I'm just going to grab it and put it up here. Okay. Now I still need the amounts, but those are also defined down here. Faucet asset to browser wallet. For now, let's just pull that one in. Faucet token to browser wallet. That looks good. All right, that's not sending any more errors at least. And the PPBL 2024 token is this right here, connected contributor token. And we'll just hard code 2 ADA, 2 million Lovelace onto that like before. And so I can actually grab this and use that as my asset right here. Okay, little by little, this is looking better. And I've got most of what I need. Ooh, output faucet assets. Yeah, that's going to be the output to the validator. All right. And now we don't need these lines anymore. Okay. So now we're getting closer, but we probably want to define these TX ins. This is where we're now going to want to go back and review some of the existing code right here. For example, faucet asset to browser wallet, right? Once again, if I look at the signature for TX out, it says that I need to provide an amount, which is a list of assets. Asset is a type provided by Mesh, right? Imported from Mesh SDK core. This variable, faucet asset to browser wallet, is defined where is it defined? There it is. Okay. And yeah, indeed, that's asset, right? So this is the faucet token asset ID. It's just the concatenation of policy ID and token name. We're sending 1 million of them with 2 ADA. And you can just see the reason this is presented like this is to show students that one way you can set up an asset is by just defining it like this, right? Storing it as a variable. We can, in a TypeScript file, give it the type asset list, which it's supposed to have. And that's why we're able to pull it in down here. But look at what we do on the next line. We didn't save the next asset as a variable, but hopefully you notice that this bit right here has the same format as this variable that we created up above. It doesn't matter which way you do this. Personally, I think this way feels cleaner. I like defining my asset lists up above, but I could imagine that some people would like just to see all of those asset amounts in one place and maybe just include something like this directly in the transaction. You've got both options, and this is presenting that to you. Output faucet assets follows this pattern. Let's find that one. Output faucet assets. This is a use state hook because we have to check the current amount of tokens in the faucet. And then once we know that amount, we can subtract the 1 million that's being sent right here. This is a hard-coded value, right? But we subtract 1 million and whatever's left, we're going to send that back to the faucet, updated quantity to string. So that's how we get that amount. Once we create this asset list right here, we set the value of this hook, output faucet assets, and that's exactly what we're pulling in right here. So all that looks good. I'm going to check the reference UTXO in a minute. I'm going to check this redeemer in a minute, but let's first figure out how to get these TXNs. Remember that we want fees and the PPBL token. And we didn't do anything with this, right? We have an input faucet UTXO. All right. So let's quickly draft a helper function that this already exists elsewhere, but I want to do this live just to kind of think through how to build the function we need. And maybe this can then help us think about where this might fit in the course if this is an exercise we want to encourage others to do. Of course, anybody who finds the link to this video is going to be able to find the answer to it. That's all right. So first things first, we're already using some mesh hooks to get the address of the connected wallet, and then we get this wallet object that we can do a bunch of stuff with. Let's go to the mesh docs for just a second. If I look at browser wallet, actually, let's look at hooks first. React wallet hooks. All right, so use wallet gives us this wallet object. What is wallet? Oh, it's a browser wallet, right? So this exposes everything that browser wallet provides. That's in a different spot now, but it's right here. Okay, so we're able to jump to browser wallet because we have one already defined right here when we use the use wallet hook. Now, use wallet provides a bunch of other really helpful stuff as well for managing the state. This can really help you build a nice UI that's always kind of keeping the user up to date about the state of their wallet connection. But we're just doing something basic right here. We're only using the browser wallet part right here. And if I look at the type of this, I should see, oh, my TypeScript server failed. So we'll come back to that later. All right, so anyway, we have a browser wallet. Let's go look at that doc now. Wallets, browser wallet. So wallet exposes to me a couple different things. Balance, for example. This seems pretty helpful because as you can see right here, this is going to return a list of assets. We were just talking about creating new lists of assets, right? This should look pretty similar, unit and quantity. And so this could help us just find out if the connected wallet holds a PPBL 2024 token. That's actually already taken care of right here with a custom hook. But if we look at the definition for that hook, it's in this directory. Sorry, I can't skip straight to that, but I'm going to go open this. If we open up the hooks directory, use PPBL 2024, and this is provided just as a first example that Mesh really makes this easy, right? So we can call one hook inside of another, but what do we do with wallet? We're going to use a function that says get assets, and then we're going to map through those and find out if any of them have the policy ID of the PPBL 2024 token. Now it looks like maybe as get assets been replaced with get balance. Looks like it. I don't see get assets anymore. So, oh, but I'm not sure. I don't know if this is deprecated documentation or not. All right, so I'm going to put that on the list. Another thing to check in on later. Because, yeah, I'm actually not sure what's newer. So I'm not going to change that yet. If it breaks, if my use of get assets breaks and doesn't give me the transaction I want, one reason might be that I have to change to get balance, but I'm not going to do that right away. As far as I'm aware, this hook still works, and it's not throwing any errors down here. I can fix this. Yeah. All right. It's not complaining, so for now I'm going to use that, but we might want to look that up later. All right. So all right. Sorry, I lost my train of thought for a second. It's not sufficient just to see a list of assets if what we're trying to get are UTXOs. And when I look at the current documentation here, get change address. Ooh, this looks helpful. Okay, I guess we don't really have to write that helper function. Let's just use this, fine. All right, that's a good thing to use first. So we see that wallet has a get collateral function on it that returns a mesh style UTXO. But if we have this, we can get the output index and the TX hash we need. So how does React work? Well, we're going to load this application into a user's browser, right? And when we do, we don't know anything about their wallet because they haven't connected it yet. After the user connects a wallet, now we can see the address of that wallet. We can get the browser wallet mesh object for that wallet, and we can run get collateral on that. This is why React hooks exist. So if you've ever seen use effect and use state, and you're wondering why we need them, the case we have right here is a really nice example. Watch. Inside of this function, I'm going to say, what is some variable that I'm going to need to know, but I can't know right now when I build this application, and I won't know until after a user starts to play with the app? Oh, well, an example would be the collateral UTXO for the connected wallet. So let's define first a use state hook. Okay, collateral UTXO. And this requires set collateral UTXO. These names don't have to follow this pattern right here, but they almost always do. Okay, there's no reason to be creative here. Give the variable a name and then write the name of a function that's going to be used to set the value of that same variable name. You put those in square brackets, and this is going to be use state. Now the type of use state, because I'm writing in TypeScript, it's really nice to define it right here, is going to be a UTXO, or it might be undefined. And before the user has a connected wallet, it's definitely going to be undefined. Let's start there. Syntax looks good. I have a warning that I'm not using either of these yet, but other than that, no complaints. So the use state hook is used to create variables when we don't know what they're going to be, and then we create functions to set those variables when time comes that we do. But how do we actually set those variables? This is where use effect can really come in handy. So I'm actually going to move to below where I define everything. We'll talk more about why later on. It's a little bit beyond scope, and we have only a few minutes left. But you can see how my different use effects hooks are coming in down here. I want to create a new one that says we're going to run some function, right? Open and close parentheses, some anonymous function. It doesn't need a name. And that function is going to go inside of these curly brackets. Then we're going to have some square brackets where we put the dependencies to run this function. In other words, whatever goes in these square brackets right here is the variable we're watching for. And whenever this variable changes, we're going to run whatever function we write right here again. So watch. Well, the collateral UTXO depends on whether wallet is defined as a browser wallet. So let's make that our dependency. Whenever wallet changes due to somebody connecting the wallet, say, let's run a function. In that function, the first thing we're going to do is check, well, is there a wallet connected? Right? And what this does is it says, okay, when you first load the page, or you first run the page or the application, right? Use effect will always run on first load. But when it runs on first load, we already know that there's no wallet connected. So let's only run this function if there's actually a wallet connected. And actually, that last thing I said is not true. If you build the right kind of application, it's definitely possible to navigate to a new page in the app and for the wallet to still be connected. So certainly on first load, maybe it's true that there is a wallet. But at least we know that we only want to run this logic if wallet is defined. Now, if wallet is defined, what are we going to do? Well, we're going to try to get the collateral UTXO, right? And so one way to do this is just to set up a new variable inside of our function right here. I'm going to give it a name, and I like to use this convention of putting an underscore inside of like a temporary variable that I'm only going to be using in the context of my use effect hook. You don't have to do it this way. This is just a matter of taste, and it helps me see, okay, right up here, name is defined, redeemer is defined only locally to this use effect hook. And I want a collateral. Let's just call it col for now. And that's going to be equal to wallet, which I've already checked whether that exists. And then I'm going to use this get collateral. Ooh, look at all that new stuff. Get drep, get pub drep key. Wow, we're going to have some fun with that. Let's go. All right, but for now, get collateral. That doesn't take any parameters. There's no complaints here. So far, so good. Now, if collateral is returned, now I can go the next step, right? And it's not expressly necessary to check for this, but it's worth it. If collateral, or we could say if not collateral, you might say, well, what's the point of that? But it can be helpful to put a not when you want something to be true, because then you're guarding against any kind of undefined or null case that might not be caught here. We have both of those options. That's a little bit beyond our scope as well. But let me say not collateral, right? This thing just ran. There is definitely some kind of truthy value to our collateral value. And if that happens, now we can set collateral UTXO as col. Fine. Now our types don't look great here because this has a promise type. Get collateral doesn't just return a UTXO, actually it returns a list of valid UTXOs and it returns them as a promise. A promise is just a way of saying, hey, you're going to get this information eventually. Whenever something returns a promise, we want to make sure to await it. So that's going to clear out that issue, but now it's only allowed inside of async functions. So this is where we're going to come down here. Let's do this. Let's define a quick little function. Call it any name you want. I'm going to rush pretty quickly because I know we're running out of time. But I'm going to write a little helper function right here that actually does this logic right here. Okay. And then I'm actually going to call that function only when get wallet. And I got to define it first, of course. That makes sense. And I should be able to avoid this. All right. So now I still have one error right here. I'm treating this like a single UTXO, but actually it's a list. So if we have call defined and this, which is a list, has length greater than 0, then let's not pass the whole thing. Let's just pass the first element in that array. We'll assume that the first collateral UTXO is good enough. Okay. Now, last thing we'll do for today is once we have that defined, now down here, we can use that collateral UTXO that we just defined. And remember that collateral over here only requires the hash and the index. So we can say, okay, in that UTXO, use the input TX hash and use the input output index. Now we still get an error right here. Collateral UTXO, you can't see it off the side of my screen. It says possibly undefined. And that's true because remember, when we made this use state hook, collateral UTXO has a default value of undefined. We actually won't be able to get UTXO fields out of it if it is undefined. So that's why you see some of this these if statements right here. And watch, if I add one more guard right here, I could say not collateral UTXO. Now that error goes away. And we still have a squiggly line under here because we have some other things to fix, but we're making progress. And we have just 2 more TXNs to get. This will be a fun place to pick up. Hopefully we can make short work of this next week. I'm going to push these changes right now. Obviously, it's incomplete. It's not going to deploy. I'm just going to push it to main for now, so it's there for anybody who wants to grab it. It's not going to deploy because this thing is not going to build because it has these errors right here. So we don't have to worry about it breaking the PPBL website any more than it's already broken. But we still have a couple steps to do to update this. But I hope that this kind of deep dive into Mesh and React was helpful. Anybody have any questions while I'm pushing these changes?
I think I know React State a little better now. That's cool. That was like
That's awesome.
that was a tasty little nugget. I was like, what? Oh, okay. And that makes
That's
a lot
good
of
to
sense.
hear.
And then those errors make a lot of sense because of course, because it's not defined yet. That's something that you'll wait and it'll change when it goes in. So I felt like that was a little win for me. And you know,
Awesome.
my brain definitely fills up and kind of goes on, you know, in kind of a weird spot, but I really do appreciate being able to listen in and follow as much as I can. It's good.
Thanks for doing it. Anybody else want to check out before we close out?
Jared, I just want to point out that I provided a link in the chat for anyone who wants to test their collateral is being spent. So there is a tag called script invalid. So you can, if you use it, your collateral is going to be spent. But other than that, most likely it is not possible to build a bad transaction and submit it to Cardano CLI. But if there is a custom transaction building library that doesn't follow the standards or some other protocols, probably they can build a transaction that fail in phase 2. And the collateral is going to be
Mix, I don't think so because it would, if you have a bad transaction library, it would fail in phase 1 because the node would not submit it. So you need to manipulate the node that you can submit the wrong transaction.
So what does this tag is exactly doing?
Yeah, as I said, I think it just changes some values like execution units so that you don't have enough execution units to submit the transaction. And
so if another library does that, won't that happen?
Mix, but it would fail in phase 1, so it would never be submitted where you can it would never be submitted to the mempool, and then the collateral is not taken. It would just return an error from the submitting node.
So
I've never gotten past that.
Yeah, how Cardano CLI is passing that? How Cardano CLI with that tag is passing that mempool validation?
I think they just implemented something that you can do that with your own node.
So that's the thing. I think if there is a custom node or custom library transaction,
Yeah, custom node for sure, then you can pretty sure do that.
You can do something.
But else, I think you have to use exactly, you need to serialize exactly that script invalid tag, that you can do that with your own transaction library.
Yeah. So guys, if you want to
make that a bounty, if anybody can bring us a broken transaction, that'll be a fun thing to look at together. We didn't touch Aiken today. For anybody who is learning Aiken, I just want you all to know the Aiken PBL course is in development. Hinson and I moved really fast on that last week, and he brought a rough draft of it to a live group of students in Hong Kong over the weekend. We're taking the initial content from there and moving it into a dedicated final draft of an Aiken PBL course. We'll start rolling that out, and we'll certainly show it in this space. And then from there, we'll make some quick updates to the one module where we really focus on Aiken in this course. So those changes are coming, lots of updates, and that's why our governance sessions are so essential. So for anybody watching this or just for the future, we're going to keep meeting at this time on Wednesdays, 14:30 UTC every Wednesday, at least through the end of this calendar year. We'll talk about what to do in January and beyond soon enough. And then on Thursdays, same time, 14:30 UTC on Thursdays, we do Gimbalabs Open Spaces, which is where we get together and we look at all the work we might do and we decide together what we will do. So we've got another one of those sessions coming up tomorrow. And some of these updates become really nice raw material that we could bring into those meetings, set priorities, try to drive further stuff. So looking forward to picking up with some proposals there tomorrow, and hope everybody has a good day. Thanks for hanging out.
All right,
Take care.
bye.